Chapter 6 Application of Derivatives, Exercise 6.2, sixth question. It is part 2. So we have D part of the question, that is 6 minus 9x minus x square. So let us consider f of x is equal to 6 minus 9x minus x square. So for f of x is a polynomial function, so it is continuous and differentiable in R. So we can write f dash of x, that is d by dx of 6 minus 9x minus x square, d by dx of 6, that is 0, d by dx of minus 9x, that is minus 9, d by dx of x square, that is minus 2x. So we have f dash of x is equal to minus 9 minus 2x. When f dash of x is equal to 0, we can write minus 9 minus 2x is equal to 0, minus 2x is equal to 9, or x is equal to minus 9 by 2. So we have got x is equal to minus 9 by 2. So splitting R, the domain of f into the disjoint intervals, that is, we are drawing a line segment here from minus infinity to plus infinity and marking a point minus 9 by 2 on the line segment. So we have the intervals, that is minus infinity to minus 9 by 2 and minus 9 by 2 to plus infinity. So when x belongs to the first interval, that is minus infinity to minus 9 by 2, we have the f dash of x, the equation for f dash of x, that is minus 9 minus 2x. So applying a value between minus infinity to minus 9 by 2 for x, we have the positive quantity as f dash of x. So we can write f of x is strictly increasing in the interval minus infinity to minus 9 by 2 when x is less than minus 9 by 2. When x belongs to the next interval, that is minus 9 by 2 to plus infinity. Now we have f dash of x, that is minus 9 minus 2x. Similarly, we are applying the value between minus 9 by 2 to plus infinity for x. We will be getting a negative value for f dash of x. So we can write f of x is strictly decreasing in the interval minus 9 by 2 to plus infinity. So when x becomes greater than minus 9 by 2. Now E part of the question, that is x plus 1 whole cube into x minus 3 whole cube. So let us consider f of x is equal to x plus 1 whole cube into x minus 3 whole cube. So it can be written as x plus 1 into x minus 3 whole cube, or we can write, solving inside the bracket, we have x square minus 3x plus x minus 3 whole cube, or minus 3x plus x, that is minus 2x. So we can write x square minus 2x minus 3 whole cube. So that is f of x. F of x is equal to x square minus 2x minus 3 whole cube. Now f of x is a polynomial function. So it is continuous and differentiable in R. So we can write f dash of x, that is d by dx of x square minus 2x minus 3 whole cube. So what is d by dx of x square minus 2x minus 3 whole cube? That is 3 into x square minus 2x minus 3 whole square into d by dx of x square minus 2x minus 3. Or we can write 3 into x square minus 2x minus 3 whole square into d by dx of x square, that is 2x, d by dx of minus 2x, that is minus 2, d by dx of minus 3, that is 0. Or we can write 3 into x square minus 2x minus 3 whole square into 2 is taken outside, that is 2 into x minus 1. Or 3 into 2, that is 6. So we can write 6 into x square minus 2x minus 3 whole square into x minus 1, which is equal to 6 into x square minus 2x minus 3 whole square. It can be written as x plus 1 whole square into x minus 3 whole square into the remaining, that is x minus 1. That is f dash of x. Now when f dash of x is equal to 0, we can write 6 into x plus 1 whole square into x minus 3 whole square into x minus 1 is equal to 0. So we have x plus 1 whole square into x minus 3 whole square into x minus 1 is equal to 0. From this we can find x is equal to minus 1, or x is equal to 3, or x is equal to 1. So we have 3 values for x now. So divide R into the disjoint intervals. So that for that we will be drawing a line segment from minus infinity to plus infinity. We have the 3 points for x, that is minus 1, 1 and 3. So we are marking that on the line segment. So we have the intervals, that is minus infinity to minus 1, minus 1 to 1. Next one is 1 to 3 and 3 to infinity. So first we will be taking when x belongs to the first interval, that is minus infinity to minus 1. So we have the equation for f dash of x, that is 6 into x plus 1 whole square into x minus 3 whole square into x minus 1. Here we will be applying a value in between minus infinity to minus 1 instead of x. So we will be having 6 as a positive quantity. Now x plus 1 whole square, it is whole square. So we will be getting, if we are applying a value between minus infinity to minus 1, it is negative quantity. So negative whole square. Similarly x minus 3 whole square, that is negative quantity whole square into x minus 1, that is a negative quantity. So we have positive into negative whole square, that is positive, negative whole square, that is again positive into negative. So we have f dash of x positive into positive, positive, positive into positive, positive, and positive into negative, that is negative. So we can write f dash of x is a negative. So f of x is strictly increasing in the interval minus infinity to minus 1. Now when x belongs to the next interval, that is minus 1 to 1, we can write f dash of x, that equation, that is 6 into x plus 1 whole square into x minus 3 whole square into x minus 1. So 6 is a positive quantity. Similarly x plus 1 whole square, that becomes positive, that is negative quantity becomes positive and whole square is taken. Similarly x minus 3 whole square, that is also positive, and x minus 1, that is again negative. So f dash of x when multiplied together we will get a negative quantity. So we can write f of x is strictly decreasing in the interval minus 1 to 1. Now the third interval, that is when x belongs to the interval 1 to 3, we have the equation for f dash of x, that is 6 into x plus 1 whole square into x minus 3 whole square into x minus 1. We are applying a value in between 1 to 3. So we have 6 as positive quantity, x plus 1 whole square, x minus 3 whole square, and x minus 1 whole square all become positive here. So we can write f dash of x is a positive quantity. So f of x is strictly increasing. So f of x is strictly increasing in the interval 1 to 3. Similarly, the last when x belongs to the interval 3 to infinity, we will be having f dash of x, that is 6 into x plus 1 whole square into x minus 3 whole square into x minus 1. So we have all the quantity becomes positive and f dash of x finally becomes positive. So we can write f of x is strictly increasing in between the interval 3 to infinity.